Good morning, everybody. My name is Josh, and today I'll be introducing our speakers. I am a PM for the Cloud Advocate Python team, and I work very closely with Pamela. Thanks for joining me today. Johan or Wasim, can you go to the next slide?
Yeah, go ahead, Johan.
Yeah, so hopefully you've been hacking with us for the last week, but if not, here's a little overview of what we've done so far. We've had our sessions from the 29th to the 1st, and we've had a whole weekend to hack so far. All of these sessions are recorded, so you can always go back from our landing page and go take a look at those. Coming up today, we're going to have our RAG Chat web components session today, and so I'll be handing it off to Wasim and Johan.
Yeah, thank you, Josh. Thank you for being with us today. So as Josh said, my name is Johan, and I'm with Wasim today. We will be presenting the RAG Chat version in JavaScript. So you've seen already the application in the past session that was developed in Python. And we will be presenting something similar that was developed, but this time fully in JavaScript and TypeScript to be more precise. And the main difference will be around the usage of web components, and that's what we'll detail in today's session. So just as a prerequisite, if you didn't follow the previous session, you will need to have, if you want to deploy everything on your own subscription, you will need to previously follow the steps that have been shown in the previous shows, deploying the Python version of the application. For this talk, the URL will be a bit different since it will be ending with JavaScript instead of demos. And we will present what are the differences in this JavaScript version of the application. If you don't have any version of these samples deployed already, you can still stay with us and deploy that later. Since the show will be recorded, you can always go back to the recorded version and follow back all the steps on your own after that. So yeah, why did we re-implement the whole application in JavaScript? So the main difference with the initial solution you've already seen in TypeScript. So the use case is basically the same. We implemented a chat application. It's a RAG application, meaning it's based on documents that were ingested in our backend vector database. And all the answer comes from a large language model that basically will make a search in the database to find related documents and generate a new answer based on that document. So the main difference in this version of the application in regards to the Python version you've already seen in the other streams is that everything is implemented in TypeScript and that we used reusable web components that were built with the lead framework for the front-end part. And you will be seeing also in the next slides that the Azure architecture is a bit different. The hosting is this time with Azure Container Apps. So everything is built with Docker containers. And for the front-end part, it's deployed with static web apps. We also have an additional service that's not currently in the Python application that's dedicated to ingest the data. So basically, if you want to update or add new documents to your RAG database, you basically call a web service and you can send the PDFs or the documents you want to ingest to that dedicated service. We support PDFs as with the Python sample, but also Markdown documents. And we have integration with the JavaScript version of LangChain, obviously, since we are using the TypeScript version of the code. The dataset is also a bit different, and that's mainly what we use to differentiate between the JavaScript and Python version, because from the backend side, everything is compatible. We also have a chat API, and we follow the same protocol, and we will be showing at the end of the stream that basically you can use the front end, the web components that we built and the front end of the JavaScript version of the application with the Python backend that you may already have deployed in the previous sessions. So that's it for the main difference. As always, if you want to deploy any of these samples, you need to have an Azure account, and you also need access to Azure OpenAI. So if you didn't already, you can request an access to Azure OpenAI using the link below. If you want to work on that project, everything we will be showing, me and Wasim, it will be in code spaces, but you can also work locally in the project, either using dev containers, or if you prefer to install everything, we also have instruction in the README of the repository to work everything and set up basically everything you need with Node.js, Azure CLI, and the developer CLI on your own. If you want to deploy the project, the easiest way is to use the Azure Developer CLI. So it's just basically the same instruction as the Python version. First, you need to log in into your Azure account. Then you can create a new AZD environment. And then you use the command AZD up to provision the Azure resources and deploy the application. So all of that is the prerequisite to have a working version of the application deployed. Now let's have a look at the Azure architecture for this JavaScript version of the sample, because it's a bit different than the Python version. We're still using Azure AI Search as our vector database to ingest all our documents. We're still using Azure OpenAI and all that's needed to deploy the application and monitor it using Azure Log Analytics and Azure Monitor. But this time, instead of having everything deploying in a single application, we have 3 different services. The first one is we call the indexer. It's to ingest the data, the PDF, into the Azure AI Search database. Then we have an API, the chat API. It's implemented, and the service is called the backend for us. And it's the one that will be answering the calls to the /chat API. And both the indexer and the backend are deployed using Azure Container Apps. And for the front ends, it's also a different service. It's what we call the chat website, and it will be deployed this time using Azure Static Web Apps. And to build that chat website, one of the most interesting stuff we will present today is that we have a separate package with all web components that you can reuse in different applications than this one. You can reuse it in your own projects, and Wasim will tell you a bit more about that. So just to give you enough of talk and more showing a bit of more code, I will start showing you a bit of the project, how it's structured, and how it goes for the backend. So let me switch first to my code spaces. So I'll zoom in a bit more clear. So it's a mono repository, and as I said, we have a few different packages for the various services of our application. You can see that we have the indexer. Our backend service is called the search service. We have the web application, it's the front-end part, and we have a dedicated package for all the web components. The one we will be looking first is the backend part. If I go through this application, the entry point of our /chat API is located in the root of the source code. Let me give a bit more space. And you can see if we go to the /chat, we can see our implementation of our backend. But the whole application isn't located in this project. If we go back to the slide, you can see that it makes a call at a different file that, similarly to the Python sample, we named it the chat read retrieve read implementation in that specific file. So let me open that this time. This is where we build the full RAG implementation. So I won't go and dive in the specifics of the application. It's based on LangChain. We still have one streaming and not streaming implementation. And everything is very similar to the Python sample. So if you've already seen the previous stream or the Python sample has been implemented, it's basically, I would say, the same, but this time in TypeScript. What we will do in the implementation is first get the search query, generate a query using the LLM, and optimize the query, compute that as an embedding to perform the vector search. Then we retrieve the matching documents, include in the prompt a few of the message from history if you have past message in the chat, and then basically call the completion to generate the answer. So everything in that part in the backend is very similar. So the backend is built in TypeScript using Fastify. And I will let Wasim talk a bit more about the front-end part with the web components. So Wasim, it's all yours.
Thank you, Johan. Yes, so when we sat down to design the front-end experience for this project, we had a few requirements in mind that were important for us. One of them was reusability. We actually wanted our customers and developers to easily use the chat experience and embed it in any existing application, written in any JavaScript framework or with no framework at all, using JavaScript, vanilla JavaScript or HTML and CSS. And we also wanted to offer some sort of customizations. Basically, we wanted to allow users to change some sort of like color in CSS, uh, add their like branding, their logos, and also, yeah, we wanted, again, as I mentioned, this experience to be like framework agnostic, like basically just grab that experience and use it in your existing application. So,
Sorry, Wasim, I'm just seeing that we are not showing the slides. John, can you switch to my screen so we still show the slides? Okay,
I mean,
perfect.
yeah, I mean that's fine. This slide summarizes that like those requirements, and yeah, this is why we decided, obviously, to offer that experience as part of a web component, a custom element. So this is what we built. And yeah, maybe now you can switch back to my screen, please, so I can show you live. This is the web component running inside of the existing React application that Johan mentioned, which is also part of that mono repo. So basically the application shell you see here, like the toolbar, the title, and everything, that's React, and everything inside here with the chat input, the list, and everything are part of that web component. Excuse me. So yeah, as you can see, I mean, this is a fully working experience, and also, as Johan mentioned, this is all open source, so you can check the app by yourself, and then you can dig really deeply into each section. There are like tons of features here. Like for instance, this is the customization panel. You can basically configure some advanced features for the RAG operations, but you can also, as I mentioned, change your styling and your CSS and things like, yeah, enable the brand and everything. So basically, that's all of these are baked into the web component. And so yeah, let me now show you the actual code. That's the most important part, I guess. So as you can see here in my VS Code, I'm running locally, and this is the chat TSX. This is like the chat component built with React. I'm sorry, the application shell. And as you can see here, this is where we came in and embedding our chat component that we built using, we built as a custom element using Lit, the JavaScript library. And then we packaged using the Vite CLI, and then basically just using it inside of this application shell. And as you can see, this is the public API of the web components. So basically, it accepts multiple attributes as a custom element, and then these attributes can basically be configured through the host application. In this case, this is a React, but we're also using it in Angular. By the way, I can show that to you. This is another repo called Contosa Real Estate. That's another project. But the interesting part here is that, let me zoom in a bit. As you can see, part of the portal, which is written in Angular, in this case, we are using our chat component here as we are doing with the React host. The similar manner. We are configuring a few attributes, and it just works. This is how the web works. Interesting. So yeah, now the actual implementation. This is the implementation of the web component. Really easy, right? That's easy. No, I'm just kidding. So the actual implementation lies inside of multiple subcomponents. So basically, each subcomponent has a scope, a responsibility. So for instance, here, this specific component is responsible of the voice feature, that you could see here. When I click on my microphone, I'll start talking, and basically, as you can see here, it got my speech and then transcribed it to text, so then I can probably search for it. But I wouldn't try this live here. Uh, we never know what would the response be. But basically, yeah, this subcomponent implements the voice feature, and we have other subcomponents for different features. So like for the button, for the lists, for the history, and so on and so forth. And yeah, and basically, yeah, this is the actual implementation. I will not go into the details. So basically, this is using lit elements. This is like, yeah, some custom annotations and like basically a DSL that lit element and lit custom elements offers. And then yeah, for the rest, we're packaging this with Vite. Basically, yeah, using like the default configuration, nothing special here. And then yeah, just integrating this into the existing application. So let me take a step back and remind you like of the requirements. We want this to be really easily distributable and reusable across any existing application. Basically, you can like grab that component, use it in your existing app, and it should talk. Basically, it can also talk with any backend. Like in this case, we're showcasing the Node.js backend, but you also saw previously the Python backend. But yeah, we can imagine using any server. You can like implement this with .NET or WebAssembly if you're if you want. You can deploy that as WebAssembly as long as it implements the same chat protocol. Yeah, and I think that's all for me. Now I'm giving it back to Johan. You're muted, Johan. Johan, you're muted. Oh.
Sorry, always happens. So yeah, thanks Wasim for the presentation, and we've seen how basically we implemented the front end with web components, and how basically the React application is just a shell. It's just a shell in our case, because it's the chat web components that basically does all the heavy work, including the call to the HTTP API. So just as you said, one of the main benefits is that it can be included in any kind of application. You've shown how to integrate that in React. We've done that also with Angular. It could be Vue.js, Svelte, or basically even just plain HTML would work. You can do that with any tech. That's one of the main benefits of using web components. And of course, we can do that because we're speaking basically the same protocol for the backend. If we take a look at this is the GitHub of the JavaScript version of the project. If I scroll down a bit, we have a section about how to use a different backend. So basically just using the front-end part of the sample, the one Wasim just shown, but using any backend that conforms to the chat protocol. And when I'm saying the chat protocol, actually, let me move a bit because there's currently a PR because the one linked currently in the README is not public. So there's been an update. So that's the fun part about doing live demo. I can just use that link. So it will probably be merged soon. As you can see, we're updating this sample pretty regularly. So this is, if you want to learn more about the common chat protocol that we used in the Python and JavaScript sample, there's also a Java sample that follows to the same specification. You can go to this repository that will be linked soon in the JavaScript sample, and I think it's already linked in the Python sample if you go to the README. So it tells you a bit about what kind of content is expected. Is JSON, what kind of properties are expected in the formats for the input of the API, but also for the output. And basically, that's it. Once you have that, the front end that we developed using web components doesn't care about what kind of backend works with him. Just needs an API to call. So, of course, since we're using the same protocol, it's possible to switch the backend. So to do that, you must have first deployed both the Python application and the JavaScript application. And if you want, for example, to have the front end of the JavaScript application, the one using web components, calling the Python backend, there's two big steps that you need to do. First, you need to tell the Python backend to allow the JavaScript frontend, who's deployed on a separate URL, to be able to allow this particular frontend URL to call the Python backend. So to do that, we need to set the allowed origin variable in the Python backend with the URL of the deployed JavaScript frontend. So this one, this code spaces is for the JavaScript frontend. If I used azd show, I can get the URL of the currently deployed frontend. So it's this one, it's the web app. I will just copy paste this one. And this time, I have also opened a code space to the Python version of the application. And I need to do azd offset allowed origins and just paste the URL of the frontend I want to use. So I will say, by doing that, I'm telling the Python backend to allow this URL to call the backend. Otherwise, the security mechanism in the browser, that's the CORS, the cross-origin resource sharing security mechanism, will basically forbid the calls. If the Python don't say when you're trying to call the API for the frontend, hey, I know this URL, it's okay, I can answer that. So once you've done that, you need to redeploy. I won't be doing that because it takes a few minutes, but basically you need to redeploy the Python backend. And after you've done that, you basically need to do the opposite. You need to get the URL of the Python backend. And this time, go to the JavaScript sample and set the JavaScript frontend to this time use the Python backend. So it's basically the opposite, just the same using azd CLI. We will set the environment variable backend URI to the URL of the backend you want to use. So in our case, the Python backend. So I will do just that. So it's backend URI. I set the Python backend. And then again, I need to use azd up or azd deploy to just redeploy the whole application. And once you've done that, what you have is basically the JavaScript frontend calling the Python backend. So you can mix and match any backend you want using the same technique. It will work the same. Of course, if you want to build your own custom version of the application, what's best is that you can experiment and basically just extract maybe the front-end part of the JavaScript sample, so you don't need to redeploy everything if that's you're only interested in the front-end part of the application using the web components, and then have your favorite flavor of the backend following the chat API protocol and just deploy that part. But yeah, we made it easy just to experiment quickly and try to switch the backend on the fly, so it can be done in just a few commands. So if you want to do that, we have a full, in the sample repo of the JavaScript sample. If you go to the using a different backend section, we have like the whole step-by-step instruction. So not just the general idea I put in the slide, but you have the step-by-step instruction. You can do that while still testing locally, but in that case, you need to use different URLs depending of if you want to use like the local version of your backend, the code space URL, or the deployed production URL of the backend you want to use. So everything is in there. And yeah, that's basically it for this session. Of course, for the next step, there's more streams planned. You can still register for the hackathon. And if you have questions, you can start asking them in the chat, and we'll be there for the next few minutes to try to answer them. So thank you. And let's see in the chat if there are any questions. So this one will be for Wasim. Are the web components in an NPM package?
So while this is technically possible, so yes, when you build and package your web component, you should be hosting them in NPM package, but you can also basically host them as a accessible resource. So then you can install them. In our case, we did not use NPM because we are using the same monorepo. So basically, we're just like NPM linking them locally. But yes, like the general idea is to deploy your, is to publish your web components on NPM. But this specific one is not published on NPM.
Yes, maybe yet. That's still something we have to consider. But yeah, for publishing an NPM package for publishing a package to NPM, also have to consider like the maintenance and security issue. So for now, it's all the sources are in the same repo. But yeah, as Wasim said, it's totally possible if you want to do that to publish them to NPM. So next question, I'm interested in decision to use React with the web components, vanilla.js, or more lightweight framework. So yeah, do you want to take this one also, Wasim?
I can start and then maybe you can add more context. So yeah, basically we used React because that was the existing front-end web application. But yeah, I mean, definitely you can use any front-end technology or just go with like vanilla JavaScript or even like a basic HTML page. So yeah, there is like technically no limitations on this. But yeah, I mean, the React was like an arbitrary choice. Like,
yeah, the main point when we choose to use React is basically we started from the Python sample to like implement kind of the same thing but tuned for the JavaScript version. And yeah, we wanted to show like, yeah, you can use like the same host but have a fully different implementation using web components, and basically you can switch the host. So it was basically a way to show how progressive you can go, still keeping like the same shell. For example, if you already have an Angular or React or Vue application, you don't need to rewrite everything to integrate a chatbot inside your application. And yeah, you can just drop the web component and it will work just like the rest of your apps. So next question, did the build time speed up with the move to replace React components with web components?
so yeah, I mean, we didn't measure the exact build time. Basically, we can do it, but yeah, we didn't think about doing it because the thing is like the web components is already prepackaged, so we are just embedding it inside of the existing React. And since we removed a bunch of React code from the existing app, so I guess, yeah, there's like less React code to build. So I think the build time kind of like speed up a little bit, but I think that's like, yeah, insignificant regarding the rest of the application. But yeah, we can do the exercise and like measure up the build time for next time.
We would also have to measure like how if you build from scratch the web components and the React app, if what's the overall time?
Yeah, totally.
So next, when you were funneling your front and back end into other sample code, you're saying that there's a ton of flexibility and ease of integration. So yes, that was the main point of using a common chat protocol between all the samples that we have in the various languages, is that we wanted to gather and have like a single chat API endpoint. implemented in many different ways, and sometimes even using different frameworks. I think the .NET version is using semantic kernel, so that's something completely different. And basically, the main thing is we wanted to have like a sort of building blocks, so you can choose which front end you want to have with whatever backend you want to have, so you can mix technologies. So yeah, we wanted to have that kind of flexibility to demonstrate what can be done using different languages. Do we have another question, maybe? So yes, maybe we can wrap up this session. Thank you for your time. This show will be recorded in case you want to go back to it and see a bit more of the details we went through. And if you want to replicate yourself, switching the backend or looking at the web components, you can do it at your own pace. And yeah, don't miss the next session that will happen later this day. And see you later.
Bye.